In this section, we're going to talk about elasticity of demand. Elasticity of demand is basically a percentage change in quantity with a percentage change in price. Given a product, the elasticity of demand is the ratio of the percent change in quantity to the percent change in price. So for example, if I have a price increase of about 5% and a quantity decrease of about 2%, then the elasticity is negative 2/5. Okay. Our equation for the elasticity can be found using the derivative. So we take the negative of the derivative of Q with respect to P times P over Q, where Q is our quantity and P is our price in the given demand equation. And of course, dQ dP is the rate that the quantity changes with respect to the price. Okay. There are three types of elasticity. The first is what we call elastic demand. So when we find our elasticity formula, if that value is greater than 1 in absolute value, then we say that the demand is elastic. Examples of elastic demand would be our luxury items. And so to give you an example of this, if the price for an item increases by 10%, then what happens to the demand is usually you will see less of an increase. There could be an increase, there could be a decrease, but in particular, the demand is not necessarily going to increase by 10%. So for example, let's think about jewelry. If I look at rings, for example, and the price of a ring increases by 10%, demand is likely to decrease greatly. Okay? You can almost imagine more people are going to buy it for a cheaper amount. So if the price decreases, more people would buy. But if the price increases, less people are likely to buy it. Okay? Demand is inelastic if, for our elasticity function, we get an absolute value that is less than 1. And these are kind of like our essential items. Okay? An example here would be heat or fuel. If the price of fuel increases by 10%, you're not going to see much change in demand. Why? Because here in Alaska, unless you have another source for fuel, we're still going to pay for it. We can't just not use it. Okay? You can think of these, like I said, as your essential items. Electricity would be another one for those who pay for water. Those types of things would be where changes in the price are not going to greatly affect the change in demand. Okay? And then the last type is our unit elasticity. And this is where the change in price has a direct effect on the change in quantity. If the price increases by 10%, the demand will increase by 10%, or decrease by 10%, but it's a direct correlation. Okay. Let's look at an example of elasticity. Okay, so in this case we have a demand function. Q equals the square root of 500 minus P, where P again is price, Q is quantity. And we want to find the elasticity and the type of elasticity when P equals 400. Okay? So here again, using our formula, it says the first thing we want to do is we want to find dQ dP. Okay? The rate the quantity is changing with respect to the price. Okay. In this case, since we're already given Q in terms of P, we can take the derivative directly. So we can think 1/2 of 500 minus P to the negative 1/2 times negative 1. Okay. So rewriting our dq dp is going to be negative 1 over 2 square roots of 500 minus P. So our elasticity is going to look like the negative of our dq dp times P over Q. In this case, P is our variable, so we're going to leave P as P. And Q, because that's our function, we're going to replace with the expression square root of 500 minus P. Now we can simplify this to get our elasticity. So we can see the negatives will cancel out. We'll get a P over 2 times, and the square roots will cancel out, 500 minus P. There's our elasticity function. Okay. So to determine the type of elasticity, we now plug in when P is 400. So E at 400 would be 400 over 2 times 500 minus 400. There we can see that's 100. So this is 400 over 200, or E will equal 2. From this, again, we see that E is greater than 1 in absolute value. So here we can say demand is elastic. In these next two examples, we're going to again look at elasticity and determine the type of elasticity at a particular point. The difference now is our functions, our demand functions, are given as P in terms of Q. So the price is dependent on the quantity. So when we use our elasticity function, we have to rewrite a little bit before we can solve. Okay. So let's look at this first one. P equaling 3,500 over Q. And we want to find the elasticity when Q is 288. So here, again, in order to get our E, remember it is negative dq dp times P over Q. Okay. In this case, we want Q with respect to P, but we're given P in terms of Q. So this means we're probably going to need implicit differentiation to get our derivative. Okay? So given P equal 3,500 over Q, the derivative with respect to P is going to be 1. Derivative here with respect to P is going to be negative 3,500 over Q squared. So you can use your power rule, or you can use your quotient rule, either one, times dq dp, since we took the derivative of Q. So simplifying this, so solving for dq dp, it says that if I multiply to the other side or divide, we're looking at negative Q squared over 3,500 equaling dq dp. Okay. So from here, let's get our elasticity. So plugging in for E, it says it's going to be negative of the negative Q squared over 3,500 times P over Q. Again, in this case, P is given as a function of Q, and we're trying to plug in for Q. So the 3,500 over Q is going to be divided by Q. Okay, so there's the P divided by Q. Now, simplifying this, Notice here, this is a complex fraction, so to simplify, we'll invert and multiply, which means I'm going to get a 3,500 over q squared. Well, that's essentially what I have here, just reciprocated. So this tells me E is just going to be 1. More importantly, that says E at q being 288 is still going to be 1. So here, demand is what we call unit elastic. Let's look at another one of those. Okay. So in this case, P is equal to 100e to the negative q over 200. And we want to find the elasticity when q equals 200. Okay. So again, we're looking at E being negative dq dp times P over Q. In this case, again, because I have my P written in terms of Q, I'm going to use implicit differentiation to get my dq dp. So here again, derivative of P is just 1. Derivative here, we can pull the 100 out front. Derivative of E to the negative q over 200 is E to the negative q over 200 times the derivative of the exponent, which is going to be negative 1 over 200 dq dp. Okay. Again, we want to simplify, so we want to isolate that dq dp. So here, if I look, 100 over 200 is just a half. So I'm looking at 1 equaling 1/2 negative e to the negative q over 200 dq dp. Then solving for dq dp, we see that dq dp will equal negative 2 e to the q over 200. That might take a second for you to look at, but again, notice I'm just multiplying by negative 2 and then dividing out by this, but a negative in the denominator is actually a positive exponent. Okay, so our E will look like the negative of this expression here, negative 2e to the q over 200, times, again our P in this case is 100e to the negative q over 200 over q. Again, simplifying, so we'll get a negative of a negative 2 times 100, so that looks like 200. The e to the q over 200 times e to the negative q over 200. Remember, when you multiply like bases, you add the exponents, so those will go to 0. So that term goes away, and we're left with a q in the denominator. Okay, so for this one, e of 200 happens to be 1. So here we would say demand is unit elastic. As far as your elasticity problems go, many of them are going to be of these types. The hardest ones are the ones where you're going to have to use implicit differentiation. The other ones are fairly straightforward in the sense that I can just take the derivative and plug it into the elasticity function. Okay. For all of these types of problems, you'll be asked to find the elasticity, and then using that elasticity function, plug in some value and solve.